Okay, this is integrated to 1.3.2, angles formed by transversals. The first part of these notes are going to come directly out of the book, and then the last portion of it, very small portion, is going to refer back to the note packet framework that I gave you for this chapter. So 1-81, basically have Marcos, and he sees a whole bunch of parallelogram tiles on the wall of a building. And he's trying to determine a couple of things about this. So we've got that little tile pattern off to the side, and there is a resource page that goes with this that I've linked to the notes. So you're welcome to print it out and take a look at it. And by that, I mean it's in the agenda. So we have this tiling pattern, and we're trying to answer a couple of questions. So back to integrated 1 from last year, we had this idea of a rigid transformation. So just as a reminder what those are. A rigid transformation, there's 3 of them. There is a reflection, there are rotations, and there are translations. Remember, translation just slides an object from one to the other. And then we want to describe 3 different sequences of rigid transformations that carry one of these parallelograms onto the other. So what you're going to want to do is just kind of focus on one of the parallelograms that you want to take a look at. So I'm going to go ahead and highlight 2 of them and then talk about how they map one to the other. So if you take a look at the picture now, I went through and I chose 2 of them. And one of the things that I decided to do was think about the idea of a rotation. So if I take the orange parallelogram and I rotate it either clockwise or counterclockwise, it doesn't really matter, 180 degrees, then I can get the 2 shapes to land right on top of each other. So there's my first way to do this, but I do need to do 3. I think another way that I could do this is take a look back at the picture, and I can slide the orange one down and then to the right. So basically my motion here is to go down and then right, or you could go right and then down. And then a third way I think that I could do this, and there are a whole bunch of different ways that you can. I think I can actually do a slide over here to the right, and then I think I can do a reflection. So I think I can reflect over. So that's 3 ways that I can move one onto the other. Then continuing on with this question, you take a look at part B and consider the angles inside each of the parallelogram for the pattern. Which angles are congruent? Okay, so one of the things that I recommend for this is on the resource page is to go ahead and grab some scissors and maybe cut it out and see if you can get the angles to match up. Another way to do it is to take a piece of tracing paper like patty paper or thin paper that you have in the house. You could even use wax paper from the kitchen and go ahead and trace over one of the angles. What you end up finding is that the alternate or opposite corners are going to end up being congruent to each other. So basically what we end up with is that this bottom left-hand corner, that angle, is going to be congruent to the opposite corner itself. And then we have the same situation with the other corners as well. And this is something that you might recall from previous math classes as well. And then moving on to part C, since each parallelogram is basically a translation of the other, all you're doing is sliding them around, which can be stated about the angles in the rest of Marcos's tiling. Use an e-tool. So you do have the e-tool availability on this question within the book, and tracing paper to figure out which angles are going to be congruent to each other. So my recommendation to you is to go ahead and pause this. I'm going to go ahead and use the 2 different colors that I already came up with, the purple and the blue, and I'm going to mark the ones that match. So I have all of my different angles now colored based off of what I did previously, and that would be my answer to part C. You might be able to see some relationships happening within the tiling itself. So what about the relationships between the lines? Well, if you keep taking the exact same image and you're basically just copy pasting it, then I think we're going to end up with a whole bunch of parallel lines. Now, as a reminder back from integrated 1, you were introduced to the idea of whatever the symbol is for parallel. And so underneath this whole parallel thing, I'm going to write them out for you. So if you're writing it like in a sentence or in a statement, then the symbol that you would use for parallel looks like two lines just kind of at a little bit of an angle. If you're putting it in a picture, then basically what you're going to do is you kind of put little like floating arrows on the lines themselves. So I'm going to go ahead and take all of my parallel lines. I'm going to put them all with that single marker. So those are going to be parallel. I'm going to go ahead and extend it over here also so we can see it. So that all of the ones with the single arrow, kind of arrowhead basically, pointing to the right are going to be parallel lines. But then we also have another set of parallel lines kind of running against those. Now we can't use a single one again. So let's go ahead and get used to some notation here. So it's an arrowhead, but we're going to put doubles there. So we want to make sure that we kind of stick with the correct symbols here. I wasn't so careful about the angles themselves because I know that you guys worked on angle markers a little bit more last year than going through and putting parallel markers on things. So once we have this done, then we've got a whole bunch of these parallel lines that are the green lines running parallel to each other, the orange lines running parallel to each other, and then the green and the orange intersecting. We don't know exactly how big the angle is, we just know that they intersect. Okay, so moving on to the next book question, 1-82. So now we have Julia, and Julia wants to be able to take Marcus's tiling pattern and really kind of extract the fact that we've got a whole bunch of parallel lines and these lines going through them. So I have a couple vocabulary words for you here. So one of the vocabulary words that you're going to definitely need to know is the idea of what a transversal is. A transversal is a line that is going to intersect a pair or more of parallel lines. So since I color coded that green, I'm going to go ahead and mark the transversal on the graph in green. So it is the line that is going to basically connect the two parallel lines. So it's going to cut through both of them, and that is going to be that line JK right there. So that's our transversal line. And then we needed to be able to determine which lines are parallel. So let's go ahead and color code those as well. So we'll go with blue on that. And then the lines that are parallel, well, those are going to be the two that are cut by the transversal. Additionally, we can take a look at the picture and we can see the symbols on them as well. So we see those double hash marks with the two arrows. So my blue are going to be my parallel lines. Okay, moving on to B. So we want to trace angle X on tracing paper and shade its interior. So at this point in time, if you have tracing paper, go ahead and grab it. If you don't, remember that you can use a regular blank sheet of paper. Just make sure that it's not too close to the lines on the lined paper. And we want to go ahead and take a look at angle X itself. So I'm going to take that angle X there, and it does say to color it. So I'm going to go ahead and color it in orange. So, and shade its interior. So I used orange. Then we're going to translate X by sliding the tracing paper along the transversal until it lands on top of another angle. So what I'm going to do is I'm going to take that angle X and I'm going to slowly move it up. So this idea of sliding something along the transversal, and I'm going to slide it until it fits perfectly into another location. And in this case, it's going to land right on top of where angle B is located. So I know that I'm going to take angle X. So for part B, I'm going to say that angle X is going to be slid up the transversal to angle B. So we went through and we slid it along. So which angle on the diagram corresponds with angle X? So that means that we're going to say angle X corresponds to angle B. So this whole idea of corresponding means that we can take an angle and we can slide it along the transversal. So in this diagram, X and B are called corresponding angles. There's a new vocabulary word for you. And this goes back to some of the notes that we're going to refer back to in just a moment. So X and B are corresponding angles. That means they're in the same relative position to the transversal and the parallel lines. So if you take a look at them, if we go back to the picture, we know where angle X is located. So always think about it in relationship to the parallel line and to the transversal. So if I take a look at this, I'm going to look at the parallel line that X is next to, and I'm going to say that it is above the parallel line, but it is to the right of the transversal. Now, if these two correspond, that means that they're in the same relative location to the parallel and the transversal. It's not going to be the same parallel, but to a parallel line. So we want it to be up and right. So they are both in the same relative location. So on C, yes, we are going to say that both angle X and angle B are above their parallel line. So they're parallel lines and right of the transversal. So the same relative location. Okay, so moving on to 1-83, we're now on part A. The same idea here. We want to find all of those angle pairs that would be corresponding. So if you pick one, so this is what we're going to do. We're going to start at one of the angles. We already know X and B. So we know angle X corresponded with angle B. So that one's already been identified. Remember, they were above the parallel and to the right of the transversal. Now we're going to go through and find other pairs. So another pair that I see, I'm going to go start down by X again. I know that angle Z itself, in this case, is below its parallel line, but to the right of the transversal. So I want to go up to the other parallel line. I want to go below the line and to the right of the transversal. So I would say that angle Z and angle D are corresponding angles. So go ahead and see if you can pair all of the ones up together that belong. Okay, so here are all of my pairs. I didn't go ahead and identify X and B, which you can though. And we know that corresponding angles are congruent to each other because they're the exact same size. So I went ahead and wrote them as congruence statements as well. Okay, so let's say, moving on to part B, that suppose the measure of angle B is 60 degrees. So I know that that angle right there is 60 degrees for part B. Use what we know about angle pair relationships to determine the measures of all of the other angles in Julia's diagram. Okay, well, the first thing I think I'm going to do is I already know how big angle B is in relation to angle X. So if I know that the measure of angle B is equal to 60 degrees, then the measure of angle X is also equal to 60 degrees. And I know this because those guys are corresponding angles. We already determined that. Then we need to be able to find the rest of these, and we want to try to figure out a whole bunch of angle pair relationships. So I think I'm just going to start filling stuff into the picture. So I know that this is 60 degrees as well. Okay, let's see if we can focus on where B is located. So since B is located up here in the top, let's just see if we can focus on the top, and I'll put my 60 degrees actually in that corner. Okay, going back to what we know, a couple of things that we know from last year and actually from earlier this year and from last class period. We know that if two lines put together create a straight line themselves, that those two are said to be supplementary. So I'm going to take a look up here and I'm going to create this straight line across. So I just highlighted it in yellow and extended it a little bit so you could see it. So if that means that angle B is 60, then angle A plus angle B is going to have to give me 180 degrees. So I think I can find those. So I know that, and I don't think we have to call these measures now that I think about it, because we're not using capital letters to identify them. So And they do represent the actual degrees inside. All right, so then I think we can say that A plus B is going to have to equal 180 degrees. And we know the reason for this is because of supplementary. So just get used to justifying what you're saying and then plug in what you know. We know that B is 60, and then if we go ahead and solve, it looks like A is going to be equal to 120 degrees. Okay, once we know that A is 120 degrees, it's kind of like all these little puzzle pieces fit together. Now we know that W is equal to 120 degrees because those two are corresponding to each other. So I know that W is now equal to 120 degrees, and I'm going to put those two together, and that's because they are corresponding angles. So what I want you to do is kind of work your way around. One thing that is not in this picture is complementary because there are no boxes in the corner. So let's see if you can figure out the rest of these. So I went through and I paired up my angles a couple of different ways. Ultimately, you could do corresponding. You could have done vertical angles, or you could have done supplementary. At this point, we're going to talk about some other relationships in the future. So double check your measurements against mine and make sure that we have the same. Okay, so moving on to the next page, we're now at 1-84, and this is a very, very important question is, are they always congruent? So be careful here. We've been talking about a transversal that intersects two pairs of, or a pair of parallel lines. Sometimes it's more than one pair, but ultimately we'll start with a pair of parallel lines. However, transversal lines can cross any pair of lines. So a transversal is technically any line that cuts through two lines. So we got to be careful. You really want to make sure whether corresponding angles are always congruent. So corresponding, remember, they're in the same relative location. So on our first question, we did angles that were above the line and to the right of the transversal. But you have to make sure that that's always accurate. And I would highly recommend using some sort of tracing paper here. But the first thing that I'm really looking for on these pictures is parallel, because that's kind of the dead giveaway that, as far as I'm concerned, things are actually going to match. Now, these things are identified as parallel. So I went ahead and highlighted them in orange. If they are parallel, if I were to trace the angle 135, then I am actually going to be able to slide it over and get it to match. So I would say yes in this case, but you can actually use tracing paper on this. So I would say that X is going to be equal to 135 degrees. And my reason, so kind of get used to using your vocabulary, is that these are corresponding angles. And then once the 135, thanks to the parallel line part, is in that corner for X, we can now find Y as well. And Y is going to be 135 degrees, and that is because it is vertical angles with, and that would be with X. So we know that they're going to be the same size, but we can test this out by using tracing paper or like a thin piece of paper. You can even use the different parchment paper from your kitchen. Okay, so now if I take a look at this, I see that I do have a transversal, but those two lines do not have parallel markers on them. And that's the other thing too to get used to, especially when it comes to visualization or like geometry type things. Don't let your eyes deceive you. Just because lines may look parallel doesn't mean that they are parallel. You have to look for the markers. In this case, hopefully nobody thinks that these are parallel. They clearly look like they're going to intersect each other. Therefore, if I take a look at these where the 135 degrees is located and the X is located, okay, well, they're in the same relative position. They're above the transversal and to the left of their lines, but they're not parallel. So I cannot say that X is equal to 135. And honestly, I don't know if I could figure out how big X is anyway. However, with Y, I think I might be able to figure it out. So if you take a look back at the picture, notice that y and 135, when put together, create that orange line. So I think we can find y. So that's going to be 135 plus y. When put together, they create a straight line, which means their relationship is supplementary. So just because corresponding doesn't work doesn't mean that we can't necessarily find something else. So I'm going to go ahead and subtract my 135 to the other side. Those are going to cancel, and I'm going to get equals to 45 degrees. Okay, but you cannot use corresponding on these. All right, moving on. So now we're going to take a look at part C and D from that picture. This is a great opportunity for you to go ahead and see if you can do C, D, and E. Okay, so here we've got C and D worked out. We were able on C to be able to find both X and Y because those two lines are parallel. I know because the markers are on them. So I have my reasons for corresponding and then for supplementary. However, on D, that is not the case. So I color-coded them in two different colors because I have no idea if they're parallel or not. And actually, looking at them, they don't look like they are. But again, I would believe it if somebody put parallel markers on it. And then I went through and I answered Frank's question as well. Are they always congruent? No, not at all. When do we know they're congruent? Is if the lines cut by the transversal are parallel. Okay, now we have jumped to the notes. So now would be a perfect time to pause. Go ahead and grab the framework of notes for this chapter that is linked to the agenda. And I believe it was linked to the agenda a couple of days ago when we started the chapter 1 notes. Okay, so here we are on page 7 and we have this idea of corresponding angles. So I'm just going to go ahead and kind of color code the ones that we have. So we know that angle 1 and angle 8 are going to be corresponding to each other. Again, ooh, man, we're missing something really important in this picture though. So let's put our parallel markers on there because we definitely know this is not true if they're not parallel or not necessarily true. Then we have angle 2 and angle 5. So we know that angle 2 and angle 5 are corresponding to each other. Moving our way down, we've got angle 4 and angle 7. Now we know that some of these other angles are congruent because of vertical and or some relationship with supplementary that got us there. But right now we're just color coding the corresponding angles. And then we know that 3 and 6 correspond to each other. And then the next part of the notes, and this is really it for the notes itself, is going to be on page 8. So remember, there's a whole bunch of examples on page 8. I think there's 9 examples. We filled in some of them last time, and this time we're only going to be filling in one of them since we only have one new vocabulary word for us. So if we take a look at this picture, where 3x is located is above. So it is above the parallel line and it is to the right of the transversal. So anything else that is going to be above its parallel line and to the right of the transversal, assuming that the lines are parallel, which they are, we've got the markers on them, then we know that those two are going to be the exact same size. So what we can do is we can take 3x and set it equal to x plus 20, so the measures of the two angles. We are going to say that these are corresponding angles. Remember, we need to make sure that we're justifying what we're doing. And then from here, we're going ahead and solve for x. So minus the x to the other side. So 3x minus 1x is 2x. The x's cancel on that side. We're going to divide by 2, and then we will get that x is equal to 10. So our final answer, just as a reminder, it's been, a day's worth of notes. We want to make sure that we state the vocabulary word or our reasons for being able to say what we're doing. We want to be able to state the correct equation that goes with it. And then we need to be able to show or explain the correct work that gets us to the correct justified answer.